First of all, a short introduction for all of you who never have heard something about Kobiaks. Then after this, I would like to talk about the general impact on buildings. That means I would like to explain it verbal-wise, whereas the next point, comparison with different slab systems, shows examples where I just make comparison with different slab systems to show you some figures also. And for sure, I will end the presentation with some examples. Starting with an introduction, what are we talking about? So it is about a sustainable, lightweight, material-efficient, reinforced, voided concrete flat slab. And what we are doing is not so new. As you see this picture here, I took this picture at a restaurant at the Dead Sea, and this already shows that the idea that we have, or that we are following is not quite new, because since a long time engineers are trying to create material efficient and sustainable slabs. But anyhow, we try to do it in a somehow better way, or in a more intelligent way, and in a more modern way. So as you see on this slide, we are talking about so-called void former modules existing out of reinforcement cages that are where you have integrated void formers, and these void former modules you are placing between the reinforcement layers. So first of all, you place a first reinforcement layer, the typical reinforcement of a flat slab. Then you place these void former modules, and then you add the top reinforcement layers on top of these void former modules, and then you can start concreting it. So we've got sizes that makes it possible to achieve slabs between, in this case, as you can see here, 22 centimeters and 70 centimeters. And we come up with weight reduction between 130 kilos up to nearly half a ton. And we also have got a newer system where we can start with a slab thickness of about 20 centimeters and going up to a slab thickness to 80 centimeters with a weight reduction in between 114 kilos per square meter and up to 650 kilos per square meter. Yeah, what did we do in the past? We tried to bring together different advantages of well-known and established slab systems, as you can see here in this slide. First of all, you see waffle slab, then you see, or also rib slabs are somehow the same. Then you can see a slab with capitals, and then you can see the flat slab, and the last example is a slab with pipes inside to reduce some weight. And we try to combine all of these systems together in one system where we place ball-shaped void formers in a flat slab. And as you can see here in this picture, where you have the column and where you have high shear stresses, you do not have any voids because there you need the solid area. So somehow it is an internal capital inside the flat slab. That's the idea behind it, and we are doing this since more than 20 years, and up to now we already have performed more than 14 million of square meters all over the world, and also projects in more than 25 countries. One more slide to explain the system. We had to do a lot of homework before we started, so that means we had to do all the research finding out the structural behavior of this kind of slab. And as you see here in this slides, we did not only have to, or had to calculate plastic parts to make sure that these void formers are stable enough. We also had to take care about the structural behavior of this slab and to find all the characteristics so that it's easy for every structural engineer to calculate this system. That's one very important point. We do not want to make a miracle out of it. We have developed very easy to handle calculation methods so that every structural engineer has got the possibility to calculate such a slab. Okay, that was the introduction, and as you can see here, some references all over the world from from Thailand and over Singapore, over Dubai to Germany and also United States. So in nearly every country you will find already projects performed with Kobiak's biaxial voided flat slabs. Yeah. Now I'm coming to the next step, the general impact on buildings. First of all, what is the impact on the buildings? You can see the first symbol. That means we can enlarge the spans because of the reduced weight, dead load. We can create bigger spans. The next thing is if we compare one slab system with the other system with the same span, we can reduce the construction height. Yeah. The other thing is we are reducing the dead load up to 30% compared with the same slab thickness. And if we compare it even with the necessary slab thickness of the solid slab, it is even more dead load reduction. That means up to 40% reduced dead load. For sure, it's the same numbers for the material consumption. So we are reducing material up to 40%. And that means that, for example, we also can reduce the numbers of trucks going to the building site. For example, one truckload of Kobiak's semi-shells has got the same capacity as 20 truckloads of concrete. And just imagine a building site in a city center where you have got a lot of traffic. That also helps to get some advantages. And at the end, last but not least, it is a very sustainable product because we just take away the concrete where you don't need it, and that means it is a very sustainable product. And because of the void formers existing out of 100% recycled plastic, that means that we have got very good values also for certifications like LEED, BREEAM or DGNB, all these certifications that help to show the sustainability. Okay, this is the impact, and what is the added value out of it? First of all, if you have bigger spans, you can create a better flexibility for the buildings. That's a better point. That's a good point for the building owners and also for the architects. If you can reduce the slab thickness or the construction height, that is also very important because in some cases you can even add another floor. That saves money or that helps to earn some additional money. Yeah. If you reduce the weight and the dead load, that has not only an impact and advantage for the slab itself, but it has an impact to the whole structure of the building. So we can reduce dimensions of columns, of walls, down to the foundation and make an optimization for all the structural parts, especially also in regions where you have seismic actions, because if you take away the load out of the total structure, this also helps to achieve with the calculations for seismic actions. Yeah, again, less concrete and other materials, that also means a faster building process. So if you have to work with less material, that generates an advantage in the time. Yeah. And again, reduced CO2 emission, that is a very good advantage for certifications in sustainability. Now that means increased quality of the building, reduced building costs, and increased sustainability. That's a summary of the advantage, and in each project you will find different advantages or different, let's say, weights of different advantages. The best thing to explain Kobiaks is just to have a look at one example, and here you can see the Vodafone campus. It's a small high-rise building in Düsseldorf, and in this case, I just have to show it. You see the ground floor situation here, and in this case, in the first step, the architect and the engineer said we need two columns here and a 30 centimeter thick solid slab. Yeah. And then the structural engineer said, okay, we can make some optimizations. Just remove one column here and one column there, so a bigger span, and reduce the slab thickness from 30 centimeter to 28 centimeter. Yeah. And the result has been that in total they could save 1,600 tons of concrete. And by saving 1,600 tons of concrete, they could remove all the piles underneath the foundation. That means a very big impact on the total structure and a lot of cost savings. Additionally, we saved 140 tons of CO2 emission, and that helped to get better points, in this case for the achievement of the certification LEED in Gold. Yeah. That's only one small example. You can transfer all these advantages to other buildings. Okay, that was an example, and now I would like to come to the next point, where I try to make a comparison with different well-known slab systems. So I started with a calculation of a Kobiaks flat slab. Then I compared it with a solid flat slab, that's number B. Then C is a solid slab with drop panels. D is a solid slab with beams. And E is a PT slab, post-tensioning. And there I also made different calculations because there's not only one solution, so I've compared it with 3 slab thicknesses of a PT slab. Let's start with the system. Here you can see the system. It's a quite small project, walls going around the slab, and then in the middle you have got some columns. The biggest span is 10 meters in one direction, and in the other direction you have 7 meters, and a column size of 60 by 60 centimeters, and some other assumptions, a concrete C30, 37, limitation of deflection is L divided by 300, and a live load by 3.5 kilonewtons per square meter, and an additional load of 1.5 kilonewtons per square meter. And now here you can find the results. The first slab is a Kobiaks flat slab with a slab thickness of 32 centimeters in this case, with a void former height of 18 centimeters. The next slab is a solid slab without void formers. So the slab thickness has to be increased to achieve the same deflection. In this case, it's a slab with a thickness of 35 centimeters. The next example is a solid slab solution with drop panels. Here you can see the drop panels with a thickness of 45 centimeters, whereas the slab thickness itself is got 25 centimeters. The next solution is a solid slab with beams. In this case, you've got a total construction height of 40 centimeters, and the beams are 18 centimeters high, and the slab itself has a thickness of 22 centimeters, and the distance between the beams is 100 centimeters. Also here you will find a lot of different solutions. That's only one example of my comparison. The next solution is a petit slab. The first slab thickness that I have checked is a 28 centimeter slab, so slightly reduced slab thickness. Then a 30 centimeter slab and a 32 centimeter slab. That's the same thickness than the Kobiaks slab. And with these 3 solutions, you have different strengths of post-tensioning. And now I would point out some results. As you can see here, I've added all these solutions in one table, and I want to show you the first rows. You can see the different solutions. Kobiaks slab again, it's A, solid slab, slab with drop panels, slab with beams, and PT slab. I have calibrated all the results, the percentages, to the solution with Kobiaks. So that means if you first have a look at the slab thickness, the height of Kobiaks has got 100%, and the height of the solid slab has to be increased about 9%. Also with the slab with drop panels, the construction height has to be increased by 41%. So that means a lot of more construction height. The slab beam solution has to have 25% more construction height. With a PT slab, you will find 88%, 94%, and 100%. So at the first view, it should be an advantage in this case. Let's have a look at the other results. So the next step is to have a look at the dead load. So Kobiaks, again, you will see here in the first row. You can see 100% dead load for Kobiaks. Then the solid slab had 37% increased dead load. Even the slab with the drop panels has got 2% more dead load, and also the slab beam combination at 33%. That's nearly nothing, but somehow it's an increased dead load. The PT slab, even it is has got a smaller slab thickness, has got 9% more dead load, 17% more dead load, or 25% more dead load. So that is also an advantage for the Kobiak slab if you have a look at the total structure. So the next thing is concrete. That's wrong. That's here written dead load. That's a concrete amount. These are for sure the same numbers for the dead load. And the next thing that I've compared is the reinforcement, kilos per square meter. So for Kobiaks, you will find 100% here, 11% more necessary reinforcement for the solid slab, 29% increased amount of reinforcement for the slab drop panel combination, then the slab beam combination, 11% more reinforcement. And here you will see the amount of only the typical reinforcement for the PT solution, 86%, 92%, and 96%. But you have to take into account that you have to add the PT steel as well. I haven't calculated it here. I only have pointed out you need additional post-tensioning reinforcement. That will make it more expensive at the end compared to the solid slab. And the biggest advantage, if you compare it with a Kobiak slab and this PT slab, is that with a PT slab, it is very difficult to make openings after the project has been finalized. If you have some openings due to some changes, and that is all possible with Kobiak. Yeah, this table just shows. Yes, I'm close. Yeah. I just run through the examples and then I'm finished already. Yeah? Okay. Just to show you some well-known examples. For example, the Microsoft head office in Munich. More than 30,000 square meters of Kobiaks with slimline, and it was very interesting for us because a construction company came to us and said, okay, it is typically designed with PT, can we change it to Kobiaks because we already have done some projects with Kobiaks and we know that it's cheaper at the end. One project that is right now under construction in Dubai, it's a center of excellence, it's a hospital. The solid slab has been replaced in this case. It's a project with more than 120,000 square meters and a concrete reduction of 7,800 cubic meters. And in sum, we have got a weight reduction of nearly 20,000 tons. Another example is the Asima Tower in Kuwait. This project is also right now under construction. It is the second tallest tower in Kuwait. And in this case, the original solution has been a slab beam combination with 60 centimeter construction height. And the structural engineer could change it to a 40 centimeter Kobiak slab. So just imagine with 65 stories which height you can save. So if you want to inform yourself about more projects, please have a look at our website. And for sure, please get in contact with us or with our partners, EEE here in Jordan, and you will get more information about our system. And if I've got luck, this film will start right now directly, and if not, doesn't work. No, I'm sorry, film doesn't start. So I'm at the end of the presentation. Thank you for your listening.